Hello and welcome to Maths with El Profe Lo. In this video we'll be doing some work in elementary number theory, in particular working with the Legendre symbol, right? And remember that if we have P as an odd prime number and A is an integer where P does not divide A, then the Legendre symbol denoted with a vinculum and a P inside of parentheses is evaluated as the Legendre symbol of A modulus P equals 1 if A is a quadratic residue modulo P, and equals -1 if A is a quadratic non-residue modulo P. Okay, now we have our proposition 4.5 that allows us to simplify some computations for the Legendre symbol. We also have theorem 4.8 that allows us to simplify other pieces, and we will come back and refer to theorem 4.6 as well, that tells us that if we have an odd prime number, then -1p, the Legendre symbol, will equal 1 if p is congruent to 1 mod 4, and will equal -1 if p is congruent to 3 mod 4. Okay, so notice that theorem 4.6 and theorem 4.8 are similar, but it's important to make the distinction of considering our odd prime number modulo 4 for theorem 4.6, but considering our odd prime number modulo 8 if we're working with a 2. Okay, so let's go ahead and work through this. Evaluate the Legendre symbol of 288 modulo 17. So in other words, is 288 a possible quadratic residue modulo 17? Okay, so always helps to check out your proposition 4.5a first, and to look at this and say, you know what? First off, we know that 17 is prime, and we should know that 17 does not divide 288, right? So these are our conditions that we need to have for a Legendre symbol. Okay, and that's true. Now, do we have a perfect square that is a factor or a divisor of 288? And the answer to that is yes. Why? 8 plus 8 is 16, plus 2 is 18. So the sum of the digits of 288 is 18, which is divisible by 9. All right, so here's what we can say. We can say that 288, right, the Legendre symbol of 288 modulo 17 will equal, well, let's just come over here, use our calculator, right, 288 divided by 9, that is 32. Right, so this is going to be equal to the Legendre symbol of 9 modulo 17 times the Legendre symbol of 32 modulo 17. Okay. Now, of course, we know that the Legendre symbol of 9 modulo 17 is equal to 1 because of proposition 4.5a, right? Which says that if I have something squared over my p, then the Legendre symbol will equal 1. 9 is 3 squared. Okay. We also know that 32, the Legendre symbol of 32 modulo 17, will be equal to -2 modulo 17, and that is by proposition 4.5b, right? And we say, well, what do you mean by 4.5b? Okay, well, 32 is equivalent to -2 mod 17, right? Because 32 is 2 less than 34, which is a multiple of 17. And then we could also do the following, right? That -2, the Legendre symbol of -2 and 17 will equal the Legendre symbol of -1 modulo 17 times the Legendre symbol of 2 modulo 17 by our proposition 4.5c. Right? So this first one right here, we did this using proposition 4.5c, and then just went through and used our propositions A, B, and C once again. So it's a nice little practice problem. So what does that tell us? That tells us the following. That tells us that we can rewrite this, right, Legendre symbol of 288 modulo 17, break it up using proposition 4.5c, and then further break it up as follows, right, from our information here, which would lead to the Legendre symbol of -1 modulo 17 times the Legendre symbol of 2 modulo 17. Okay? And we know that this will be equal to 1 times 1, which equals 1. Okay? Now you might say, well, wait a second. How is that going to be the case? Well, let's start with -1, the Legendre symbol of -1 modulo 17. Well, this will be equal to 1 because 17 is congruent to 1 mod 4. And 2, the Legendre symbol of 2 modulo 17 will be equal to 1, and that's because 17 is congruent to 1 modulo 8, right? That for this right over here, this is theorem 4.6, and here we're using theorem 4.8. So, what does that tell us? That the evaluation of this Legendre symbol is equal to 1. Okay. If we had Wolfram Alpha or a similar technology resource available to us, we could type the information in and just double check to see, hey, what would be the Legendre symbol of 288 modulo 17, and the answer that you would get would be that it's equal to 1. Right? And really, what's that telling us? That's telling us that 288, which if I use my modular arithmetic, 288 minus, I know I can subtract 10 times 17, right? And I could subtract another 5 times 17, right? And subtract another 17, and we get 16. And we would see that 288 is going to be equal to, or 288 is going to be a quadratic residue modulo 17, right? Which, like I said, using that proposition 4.5b, we could have simplified this much faster and said 288, the Legendre symbol with 17, will be equal to -1 Legendre symbol 17, which will be equal to 1. So this will be our fastest approach to solve this problem, but it doesn't matter the approach. We must be comfortable with what we did, right? Where on this part we would have used proposition 4.5b, and on this part we would have used theorem 4.6. Okay? So a little bit of playing around with the computing of the Legendre symbols. This has been Maths with El Profe Lo. I thank you very much for your time.